I'm actually talking about two different things. So, where you sit there and say, well, if I have the standard deviation
Big N is the whole number.
is the population. We're normally not going to know big N. Now, there are certain things that we have to be able to do to be able to use the central limit theorem. We're not going to talk about those tonight. I'll talk about those next week. Or shoot. I hate this.
Spring break. How about we just have a party on Thursday?
What is today?
Thursday.
Oh, then I can talk about it on Thursday. You guys can bring in pizza. We can finish a little bit early. Sure. Because I was thinking that today was the last day of this week and that next week is spring break and I wasn't going to be able to talk about anything else for another week and by that time.
I mean, we can do that.
But by that time, what is the problem?
Yeah.
Speaking of
Yeah, the problem is.
I was going to ask if you could open everything.
Yes,
Do it all in spring.
I will do that too.
Okay.
Open it all.
Everything.
Yeah.
Okay.
I will extend, yeah, I'll try to do that.
I'll
I'll do
remind you
that,
Thursday.
I'll do that tomorrow and
Okay.
make sure that it's done on Thursday.
Okay.
So we use the mean of the samples to estimate the mean of the population. And the standard deviation of the sample means is going to be the standard deviation of the population divided by the square root of n.
Sample population.
Yes, the sample size. So those are what we sort of start to look at. Now, the aspect behind it is we do this, and then we want to look at it and say, what is the probability that this sample is indicative of our population? And this is where we're going to be able to go back to what we did with the z-table and some of the normal distributions. Because we're going to be looking up the probability and see, do we expect this to be within that range? Okay? So those are what we're going to sort of look at. Okay? So when I look at this, I'm going to go back, and if I just look at my sample real quick, my sample said that the mean was 51.5. So that is sort of what we're looking at. So that would be my estimate of the population. Now I want to get a standard deviation. And this one gets a little bit fuzzy on getting that. And we're going to be able to predict whether or not this is a area of doing this. Now, I'm not going to give you, I'm going to get something up on La Lima because what I'm going to do is have you do a couple of different samples and just work with it. Because this is what the central limit theorem starts working with is we do lots of sampling to predict what's going on in the population, in the real world. And then we have to say, what is the probability of what this is actually doing? So that's where the central limit theorem comes in. Now, like I said, this is just a sort of, what I wanted you to do is just sort of get into it and see what we do. And this is what people have done over time. And when there are certain things, we've done sampling in lots of different areas, in the medical fields. All these hospitals, we have thousands of hospitals that sample data. And they report their sample data, and then we can use that, and we can start looking at all the different aspects of that. so that when we do if a hospital does a sample, we can compare it to all those samples that had been done in the past and see whether or not there is a probability that that hospital is actually what we expect or whether it's outside of what we expect. So what we start to do is we look at that, and when we look at a standard curve, if we go out so if we go out 2 standard deviations, how much of the data do we expect to get?
95%.
95% of the data. So what we start to do is look at that. So if we get a number and we say the sample means are normally distributed. So when we went back and looked at this, so when we went back and looked at the data of what we just did with our samples, let me see. I thought somebody got a age of, see like this one. Leola got a age of 46.64. Where would that fall on here? Well, if we sit there and say, well, we think the mean, we took the mean of the means, and we said the mean of the means was what? The mean of the means was
53.26.
53.25. And she got a mean of 46 point something. Would we expect to get that low of a mean? Would that be exceptionally small? So is her sample indicative of the population? So that's what we sort of are going to start looking at, and we're going to say, what is the probability? So what we're going to look at is we're going to take the central limit theorem. And the central limit theorem is the emphasis behind what we do. So what we're going to do is use this for building things in chapter 8 and chapter 9 and the rest of the book. But what we do is we sit there and we talk about point estimates. What's a point estimate? That's an exact point, right? So if I was to estimate, I'll pick on Jonathan this time. So I'm going to estimate Jonathan's weight is 178. I'm just taking a random guess. That means, what are the chances that I got his weight? Does anybody want to hazard a guess what the chances is that I hit his weight on the nose? Probably not even 50-50. Probably an awfully narrow window. So a point estimate says I'm getting it right on the dot. Remember what we said in a uniform or a binomial distribution? The probability of hitting anything smack dab on is 0. So if I say I estimate his weight at, what did I say, 178 pounds? Chances are that I'm not real good. So we want to get better. So if I sat there and said, I estimate that his weight is between 170 and 186. I've now made an interval. Would I be more likely to capture his actual weight?
Yeah.
Yeah.
More likely, but not.
And if I sat there and I said, I estimate his weight to be between 162 and, let me see, what did I say, 186, 194. I'd even be more likely to capture his weight. So what we start talking about is a point estimate. The mean of the sample is a point estimate of the mean of the population. chances are not very good. So what we're gonna do is we're going to take the central limit theorem, and it allows us to build on that and say, well, I'm going to build an interval and say it's, and I can decide how much I want to make my interval. Do I want to be 90% confident that I caught that mean? Do I want to be 95% confident? Do I want to be 99% confident? Do I want to be 80% confident? And what we're going to do is we're going to start building intervals and say, I think the mean of the population is between here and, so I will start to build a confidence interval where I'll say, I'm 80% confident that the mean of the population is between here and here. And I will get that by taking the mean of the sample plus or minus a certain amount of standard deviation. And that's what we're going to build to. And the central limit theorem is the theorem or the theory behind it that allows us to start to do everything we do in statistics.
But you're gonna walk us through that slowly, right?
Maybe not as slowly as you think.
No. I need to see it, I guess, step by step. Like, I can't just hear it. I have to see
Yeah.
it.
But that's what we're moving towards.
Yeah, okay.
So what I want you to do is sort of just read through the first part. I want you to read about the central limit theorem. I'm not going to give you any exercises to do.
That's chapter 6.
I just want you to read it, chapter 7, I believe.
7.
Before Thursday.
Yeah, I want you to start reading. And you don't have to read the entire chapter. So they're going to talk about it. So they talk about the central limit theorem for sample means. We sort of did that. And we're going to talk about it that they are normally distributed. And we've got a mean and a standard deviation for the sample means. Okay? And basically I gave you what these two are. We sort of used the point estimates of that. And they start talking about that. And I'm not going to sort of look at some different things, but we will look at calculating somewhat of a z-score. And remember the z-score, we were just taking the scores. Well, the scores now are going to be the mean of the sample that we just took minus the mean of what we think the population is.
Wow. Up.
So we're going to start looking at that. So it becomes real important that you understand what symbol means what. So we're going to start walking through here. So pay close attention to the symbolism in here. And like I said, we're going to talk about it. And when we talk about, I will talk about this a little bit more on Thursday. We give this standard deviation of the X bar, we give it a special name. We call it the standard error of the means. It's a special standard deviation that we call standard error. And I will talk about how to calculate all those.
Is that like a margin of error?
It is another name for it is margin of error. And they sort of talk about it. So how do you calculate the margin of error? And so what we're going to talk about it, and we're going to talk about the lower value of the area and the upper value. That's plus or minus the standard deviations. So we're going to think about how that curve works. And like I said, I'm not too concerned with doing too much calculation right now. So don't worry about the calculations. What I sort of want you to do, just read through like the first two parts. And then we will start working with it. Because the central limit theorem is the theorem, and what's a theorem? It's an educated guess. It's something that we theorize actually always happens. And the nice thing about this is, over years, we found out that most of these things are fairly correct. But remember in Excel, There were 3 different ways to calculate the sample the quartiles. And they gave us numbers that were a little bit different, and there were different formulas. There was standard deviation P, and standard deviation S, and they gave us slightly different numbers. Over years, we've gotten better at doing certain things. And the computer allows us to do things that were much harder to do even 10 years ago. So there are some aspects of that. So we're going to sort of be looking at some of these. And we will be getting more into that on Thursday. But what we do is this is all built on doing sampling over and over and over again so that we can imply something about the population. And as you can see, when we did this little exercise, we all got a bunch of different samples, and if I took the mean of the means, I got something that approached the mean of the population. And that always happens. And the more samples we take, the more accurate that's going to be. And the bigger the samples we take, the more accurate that would be. If my sample size would have been 15, our means probably would have gotten even closer. If I'd have we'd each taken 3 more people, we'd have probably done even closer. So that's what we start to do. That's what the central limit theorem sort of builds on, is that we can do this and we get back to the population. And we're going to do things, and the first thing we're going to do is make point estimates. Then we're going to talk about making an interval estimate. We call it a confidence interval. And then we're going to talk about doing hypothesis testing, which is just another way of sort of looking at it and saying, how good do we think our guess is? Do we think we can rely on it or not? But everything that we do from here on out is going to be using probabilities, looking up probabilities in the Z table and the T table and different tables, and being able to work with the central limit theorem to make predictions. So the central limit theorem, there's really not a whole lot to work with that. It's just what allows us to do what's left in the semester.
Okay.
So I just sort of set that up tonight.
And is that gonna be it after that? After that, just practicing?
It's just gonna be doing, first off, we're gonna do point estimates, then we're gonna create confidence intervals, and then we're gonna do hypothesis testing. But hypothesis testing all builds on being able to work with the different tables. The Z table, the T table, and the chi-square table.
Oh my
So we're
goodness.
gonna look at those different aspects. So you're gonna have to be working with probabilities.
Thus the reason why there's not many math tutors.
Huh?
Said thus the reason there's not many math 115 tutors. I figure everybody who passes this class is like, I never want to think about it again.
Actually, a lot of the nurses and that I run into on a regular basis that have taken this class have actually come up to me, and the aspect behind it is you're not going to have to do a lot of the calculations because Excel does the calculations for you. But as the comments that I've gotten from people is, I've gone to a conference and they outlined what they were doing and they talked about their research and their studies. And I now understand what they're talking about when they report the statistics.
Good.
See, that's the important aspect of it. And with statistics, is being able to sort of wrap your mind, and I know it's not going to be a perfect wrap,
Yeah.
But when people start talking about, why did Donald Trump beat Hillary Clinton when all the polls said Hillary Clinton was going to win? And we will talk about things like that. That has to do with sampling and sampling errors and how this works. Huh? No, it had nothing to do with the Electoral College. It had all to do with how people sampled.
Maybe because they were like, I'm just gonna click Hillary. I'm just gonna click Hillary.
Well, they didn't have a good sample then.
But then,
Well, it's
they had a
because
big margin of error.
it's because of A, how they sample, B, what they were looking at, and that they didn't take in consideration the
bias?
margin of the sampling error or the margin of error.
Was it biased to one side?
Oh, yeah, they were definitely biased to one
That
side.
could be another factor.
There was a lot of bias in a lot of the polls.
Yeah.
So, yeah, that's why there were actually some polls out there that had it picked actually correct, but nobody paid attention to those. Huh?
What do you think would happen a year later?
Well, they did the same thing when Barack Obama won. Certain people were predicting polls, nobody had him winning. No, it's because there were a lot of people who were saying, no, there was no way he was gonna win, when all the polls were saying, yeah, he was gonna win, and the margin of errors and everything supported it. So the fact that he won shouldn't have been a surprise. It wasn't a surprise to most statisticians. We got what was expected. But some of the people that were looking at the one with Hillary and Trump were looking at certain things, and they were making some aspects behind that. And we will talk about how those sampling errors come in. And it has to do with how we sample and how we calculate these, and whether or not our sample is a good predictive sample or not. And that's all that we will talk about with confidence intervals and hypothesis testing. But it all builds on this.
Are you able to open up the homework so we can,
Which homework?
the one you just, the
What, you
one,
wanna redo it? Okay,
well, there's
I think I
some,
can do that.
I wanted to fix it. Do we get graded by this homework?
Exactly.
Huh?
Sorta.
We do.
Does anybody remember how we said, how the grading of the homework sort of works?
As long as you attempt, you get a grade.
I guess I want to understand it all too, so.
Did you get tested? For bio?
Did I what?
The test for bio?
What about it?
What did you do?
I did, okay, there's like couple things, I was like